The next reaction we'll take a look at in our series of reactions, a type of reaction known as a decomposition. The identifying feature in a decomposition is we have a single reactant. It's the only one of our reaction types that has a single reactant, and that single reactant gets broken down into two or more products would be our identifying trait of a decomposition reaction. So in this circumstance, it's essentially the reverse of a combination reaction. We start out with one product, and that one product gets broken apart into two or more pieces, and that would be a decomposition reaction. We now have a series of decomposition reactions to look at, starting with our first one. Here we have something where metallic carbonates are going to decompose specifically into what we call metallic oxides and carbon dioxide. In this example, magnesium carbonate, that's MgCO3. Magnesium is a metal, so this will be classified as a metallic carbonate. This will decompose into a metallic oxide. Magnesium is a +2 ion, oxygen's -2, so this magnesium oxide would be MgO for our metallic oxide, and then we also make carbon dioxide gas. And this would be our example of a metallic carbonate decomposing into a metallic oxide and carbon dioxide. Another decomposition is we have something known as a metallic chlorate. Those will decompose into a metallic chloride and oxygen, elemental oxygen. In our example, magnesium chlorate, this is MgClO3 If that's heated, it's going to decompose into a metallic chloride. In this case, magnesium is our metal, which is +2. Chloride is -1. So our metallic chloride is MgCl2, and we're going to make oxygen gas. Putting a 3 in front of our O2 balances the equation, and here we have an example of a metallic chlorate decomposing into a metallic chloride and elemental oxygen. Some of our decompositions are very specific. Here we have a compound, specific compound, ammonium carbonate, that's going to decompose into ammonia, water, and carbon dioxide. In our example, we'll say ammonium carbonate is heated. Ammonium carbonate, ammonium is 1+, carbonate is 2-. So it's ammonium NH4 CO3. This will decompose into ammonia, which is NH3, water, H2O, and carbon dioxide, CO2. Placing a 2 in front of our ammonia balanced the equation, and here we'd have an example of ammonium carbonate decomposing into ammonia, water, and carbon dioxide. Another decomposition is we have sulfurous acid that will readily decompose into sulfur dioxide and water. In our example, sulfurous acid, that means it comes from sulfite. So the formula of sulfurous acid is H2SO3. That's going to decompose into sulfur dioxide, which is SO2, and water. Now this is actually the reverse of the combination reaction. If we took SO2 and water and put them together, it would turn into sulfurous acid. In this case, by heating the sulfurous acid, we drive the reaction backwards and make a decomposition reaction take place. Our next decomposition, again very specific, carbonic acid will decompose into carbon dioxide and water. Carbonic acid, being an ic acid, comes from carbonate, CO3 2-, so the formula we have H2CO3 for carbonic acid. It's just going to decompose into carbon dioxide and water, H2O. And this is balanced as is for this decomposition reaction. Our next decomposition is specifically something known as a binary compound, meaning it's made up of two elements, may break down just to produce two elements in their elemental form. An example of this, we say molten sodium chloride is electrolyzed. Now electrolyzed means we're inputting electrical energy. Now sodium chloride is plain old table salt, And what this will do to the binary compound, by adding the electrical energy, would turn the ions in sodium chloride back into their elemental form. So this will turn into elemental sodium metal plus chlorine gas, which is Cl2 in its elemental form, in that it's one of the Hunkelbrief series. We can balance the equation by placing a 2 in front of the NaCl and a 2 in front of the Na, and we now have a decomposition reaction for a binary compound being split apart and returning to its elements. Another decomposition reaction, we have the hydrogen peroxide compound. That'll decompose and turn into water and elemental oxygen gas. Now, hydrogen peroxide is H2O2. This will decompose, just turn into water, H2O, and oxygen, again, because it's one of the Hunkelbriefs, would be elemental oxygen is O2. You can balance the equation by placing a 2 in front of the peroxide and a 2 in front of the water. We now have a balanced equation for our decomposition of hydrogen peroxide. The last decomposition we're going to take a look at, we have the compound ammonium hydroxide. That's going to decompose into the compounds ammonia and water. Ammonium is NH4 plus, hydroxide is OH1 minus, so our compound ammonium hydroxide is NH4OH. That's going to decompose. Ammonia is NH3, and then water, H2O. And this would be our final decomposition reaction example.